can still do it.
Yeah, I'll try to find
It's
it.
good in audience.
I'll vote for you.
Did you vote for me?
I did, yeah.
Thank you.
Everybody tried telling me to vote for Liza.
Bro, what?
I
Thanks
said,
for not being a sellout.
I said no, and I actually convinced some other people to vote for you as well.
Appreciate it.
Everybody's like, oh, vote for Liza. But she is so irresponsible. I'm like, no, vote for Thompson. I convinced
Appreciate
two
it.
people.
The quiz next class?
No, I had a terrible life. It was bad. I started my E major skill on an E. I messed up almost all of my sight readings.
Wait, can you go to
The only good thing I had going for me was stare.
And then
My tympany was okay. It wasn't great. But
survey.
my keyboard was just downright trash.
There.
Even then though, Grace only made Berkshire third band.
Okay, you don't have to vote for me.
I'm voting for you.
How many bands do I have at all?
Thank you.
3. Wow. I'm just sad though, because I lost to Jack again.
That is frustrating.
Very missing a bunch of people today.
I guess so. Yeah. Where's everyone?
Where's Diego?
Diego is out today.
Right here, bro.
Oh.
Apparently, so both Caleb and I didn't get in. I don't really care because I only did classes for a grade. But apparently, yeah, all regions for a grade.
Oh.
And then I made all or qualified for
Oh, we do got a bunch out now.
Caleb did get in as well. and
School
apparently he
business,
said, hey,
parent
Max,
contact, school business.
She like really hates it.
The straight.
We're starting on
Okay, Miss Wallace.
To like higher up.
Caleb Wall.
I'm pretty sure, yeah.
Dude, why would you do that?
Christian.
No, it didn't come from me because I'm not 100% sure. But that's what I was.
Well, that's not gonna change what happens. And unless they just really don't care, I'm sure they're gonna relay that back to Mr. Ruska. So.
What are you guys saying about?
We had all-state tryouts on Saturday.
Yeah.
And one of the people in percussion didn't make it, and they supposedly sent hate emails to the people who run.
Oh, actually, who was it?
You're not in band, so I'm not gonna tell you.
Okay. This is personal.
Okay, we are moving on, guys. We've got, so it's been a while since I've seen y'all, since last week was a B week. I didn't see y'all on Friday. This week is an A week, so I will see you on Friday. But just in case you don't remember, there is no school next Monday, so I will miss you on that day. That is a teacher work day. But we finished up limits last time I saw you guys. And then the next big thing that we want to spend some time on is actually logarithms. And even though you should have seen logarithms in Algebra 2, if it's anything like when I taught Algebra 2, it was only like 2 weeks, so it's kind of an introduction. And logarithms are actually really important for basically anything in mathematics except statistics. Statistics don't need too much logarithms. But before we can get to logarithms, we need to, right before that, we need to review exponential functions. And before that, we're going to review inverse functions. So that's what we're doing today. And the reasoning of that order is we're going to review what it means to be an inverse function today. Just one day on it. We'll quiz a couple of those topics next class, which would be Wednesday. Then we'll do exponential functions. And the thought process is that exponential functions and logarithmic functions are inverses. So once we review what an inverse function is and what it looks like and all that kind of stuff, or sorry, an exponential function, then we should by default know a little bit about logarithms before we even start it, because they will be inverses of the exponentials. So we've got 2 handouts today. Both of them are pretty short, but 79 is the one I would like to walk you through and just kind of show you from scratch. as some notes, and then I'm going to give you 10-15 minutes to try the second handout as a rough practice quiz, just to give you an idea of if you remember much of this, or after the short reminder I give you on the notes, and to help you identify what you need to know. So in theory, you've heard all of this before in Algebra 2, and I'm just helping you re-remember it because you may not have used it some. But of course, you may have forgotten some of it. Some of it you may not have really learned the first time. Some of it you may have learned long enough to do well on the test, but you didn't really put it in your long-term memory. And of course, just depending on your algebra teacher and how much time you had, some of these things may not have come up. But these are the things that you need to know about inverse functions. So the first is how to find an inverse function. So you should start off by switching or swapping the input, which is usually x, with the output, which is usually y. Now, we actually did do a little bit of inverse stuff last semester in trig, but we didn't really spend much time talking about what an inverse function was or the algebra behind it. It was more just what we needed to know to be able to do the trig questions. But as soon as you switch input and output, then you should solve for your new output, and then change y into this notation. So f of x is the original function, and this guy with the little -1 looking exponent represents his inverse. Now, it's not really a -1 exponent, there is a slight difference, but that is consistent with what we did in the trig stuff. Like sine, inverse cosine, inverse tangent, they all had the little -1 looking exponent, so same idea. So to show you an example of this, if I wanted you to find the inverse of this, you should swap input and output. Step 1, solve for y. Step 2, and then before you circle your answer, if you want to call it an extra step, I guess step 3, don't say y equals, say this. The problem with saying that it's y equals is we're also saying y is 2x plus 1. Why can't it be equal to 2x plus 1 and equal to x minus 1 over 2? Unless x is something very specific. So we don't want to say y is this and y is that. This is the original function. This is his inverse. So switch x and y and solve for y. That part sound familiar? You've done that before? Okay, then next up, how to determine if two functions are inverses of each other algebraically. Algebraically is the only way to prove or to verify that two functions are inverses of each other. And to do this, if you're talking about f and g, you would have to plug one of these functions into the other one and the other way around. And when you simplify them, if they're really inverses of each other, they will both simplify to be x. But that's the only way to prove for sure that two functions are inverses of each other. So to show you an example of that, so we know these two are inverses. These are the same two from question 2 or question 1. So for you to verify or to prove that these are true, one time you should plug all of this into this guy. Everywhere there's an x, you put a 2x plus 1. And then another time you should plug all of this in over here. So instead of a 2x plus 1, it's a 2 times this entire function plus 1. And then you need to simplify each one. So plus 1 minus 1 cancels out, times 2 divided by 2 cancels out, times 2 divided by 2 cancels out, minus 1 plus 1 cancels out. You need to show that both directions simplify to x. So that would be a composition of functions when you plug a function into another one. Now, if you plug them into each other and they don't simplify to x, that means one of two things. Either they're really not inverse functions, or you're making a mistake. your arithmetic's off. So, but that is the only way to prove that they are really inverses. If you are okay with being 99% sure, this would be good for like ACT or multiple choice questions. Usually you can eyeball them and see graphically. So to do that, you'd want to graph both equations and then look for a line of symmetry at y equals x. So this is, again, this is not good enough for a mathematical proof or justification, so really this shouldn't say verify at all. We should cross that out. But if you were taking the ACT, did anybody do the ACT last weekend? Okay, I was just curious if there's any law of sines, law of cosines. But let's say they give you a function and they say find its inverse, and one thing you could do, let's say that this was like just choice A. You could graph this in your calculator. He has a y-intercept of 1 and a slope of 2. I'm just going to do a quick little sketch, but on the ACT you'd have your calculator. Also graph this guy at the same time. I'm going to split apart the fraction there so I can see what the y-intercept is and the slope. And to be honest, I usually graph y equals x also. So I just put in all three equations into my graph. Y equals x is a line where x and y are the same value all the time. And do you see how this is a line of symmetry? How it's cutting the graph in half? Or if you were to flip over the purple line, it would land on the red line. Or if you flipped over the red line over that, it would land on the purple line. Now, it doesn't look perfect because I've just got a rough sketch, but it's usually pretty quick to just graph this, and graph y equals x. And again, as multiple choice, if it doesn't look like it has a line of symmetry at y equals x, then you would know that's probably not it. Try choice B, try choice C. But because it has that, it's usually pretty safe to say that they are inverses. I don't know this, but I was thinking about this earlier today, just something I've never investigated. But the fact that these two simplify to be x when you're proving that they're inverses, and the fact that they have a line of symmetry at y equals x, I'm sure there's some relationship there, but I don't quite know what that is. I haven't thought about it yet. Okay, and then finally, the last little part of our notes before I have you do the practice quiz. We will go over it, but I do want you to try it on your own. You need to remember the vertical line test is how you know if something is a function, whereas the horizontal line test tells you if a function's inverse is a function. And we need to squeeze in a term right here. There's a vocab term that usually comes up with this. 1-to-1 means it passes the vertical line test and the horizontal line test. If it passes both of those, we refer to it as a 1-to-1 function. Vertical line test, it's a function. Horizontal line test means his inverse is a function. If it passes both, we call it 1-to-1. Okay, I feel like we talked about that a little bit last semester, so all that fairly familiar? Okay. All right, and then the last part I need you to put on your notes is how some points on a function relate to points on an inverse and vice versa. So let's say we gave you a couple points on the function. Let's do like 0, 0, 1, 4, and I don't know, -2, -3. You should be able to turn those into points on the inverse, because all inverse means is you're switching input and output. You're swapping x and y. So 0, 0 swapped around is still 0, 0, but 1, 4 would be guarantee a point of 4, 1, and if the function had a point at -2, -3, the inverse would have a point at -3, -2. since this is just a couple quick points, I'm going to go ahead and make a quick little sketch. So here's F. And then if I plot these, just a quick little visual, even though it's only 3 points. But again, my graph's not perfect, but notice there's a line of symmetry here at y equals x. That's what happens when you switch x and y. 1, 4, so when you switch it, becomes 4, 1. 0, 0, switch becomes 0, 0. -2, -3, switch x and y, it flips it over that line. That's why that symmetry exists. Okay, and then the last part I need to tell you that comes up, or we will expect you to know in some way or another. If you are talking about a function and you know his domain and range, domain means possible x's, domain means possible y's, then you should know quite a bit about the inverse function. The possible x's for the function become the possible y's for his inverse, and the possible y's become the possible x's. So the domain and range of the function become the range and domain of the inverse, and vice versa. Sometimes that's useful. Now, I also like to point that out down here at the bottom, because with these, even though there's only 3 points for each of these, you can visually see what I'm talking about. For F, this would be his domain, the x values that it hits. His domain ends up being this guy's range, and his range ends up being this guy's domain. X's become y's, y's become x's. Domain becomes range, range becomes domain. I think that came up a little bit last semester, but just not a ton. Okay, so before I set us a timer here for you to do the second handout, is there anything in here that you don't remember learning in Algebra 2? Anything that just sounds completely different, unfamiliar, that you'd like me to talk on again? Yep.
I'm sorry, I forgot to look when we first got it. What number is this for numbers?
This is 79, and the second one will be 80. Okay, then before I set our timer, I do need to tell you something about there's a math competition coming up called the ACTM. I know some of you may have heard about it if you were in Nu Alpha Theta, because I think he's offering you like an hour or something of your times if you participate. But in case you're not in Nu Alpha Theta and you're interested, or even if you are in Nu Alpha Theta, if you're interested, I don't know how much of this has been relayed to you, but it's a math competition. You are certainly encouraged to participate. You may not have heard of it before, just because the last couple of years have been really low-key with the COVID and stuff. This year is more back to normal. One downside to it is a test Saturday morning. It's March 3rd or March 4th, whichever one of those is a Saturday. So if you're interested in doing it, it's 10 in the morning at the university. But the part that I'm pushing you on right now is there is a $5 fee to sign up. So if you want to do it and you're interested, then I'd love for you to, but I need to I cannot sign you up officially until I have your $5. And I need that by the end of the week if you're going to do it. Because there's a process where I have to get all the money into someone on campus. They change that to a check. The check gets sent over to the university. So if you miss your window, you don't get your $5 in by this week, then it'll be out of my hands and I can't do anything to get you on. So if it's important to you, just make sure that you bring it as soon as possible so that that doesn't happen. It is a tough test. People usually think it's harder than they expect, but it's a regional test. So that means everybody in the region, Springdale students, Rogers students, Haas Hall students, Farmington students will be there. And not everybody teaches pre-cal in the same order as us. So the test would have some like logarithm stuff on there, which we just haven't gotten to yet. And it might have some conics on there, which is a thing that we usually just don't even get to. We just prioritize other stuff. But it's got to be a random assortment to be fair to all the schools in the area. So if you want to compete and you want to aim to do very well, if you do well enough, they will tell you if you get first, second, third, or an honorable mention, which always sounds good when applying to schools, colleges, or for scholarships. And usually if you get top 3 and then like usually 4th, 5th, 6th, that part changes year to year, you can get invited to go to the state competition. And if you do well enough at the state competition, I think you can earn a small scholarship. But even though it is hard, I think one of the last regular years, it was like 4 years ago, I think, one of my pre-cal students won at the state level. So she did well enough to get invited to state, which is not that uncommon, that we usually have a few. But she actually went and had the highest score at the state level, so she won a small scholarship out of it. So I only say that because even though it's tough, if you're serious about it and it's important to you, it is doable. So, but anyway, if you want to sign up, just make sure that you know, if I don't get you $5 this week, then I probably can't get you in because it'll be out of my hands.
How long does it take?
That's a good question. I think it's usually like a 60-minute test. Yes. So the test officially starts at 10, but they recommend you get there at 9:45, and it ends around 11. Some people choose to stick around and have lunch together. And then there's like an award ceremony where they'll be like, you know, 3rd place goes to this person, 2nd place goes, so you can like stick around if you're interested in that stuff. But
Cool.
there's also like Algebra 1 gets to do it, and Geometry, and Algebra 2, so there'll be a bunch of people up there. But it is a pretty big commitment to have to get up early on a Saturday and do that. But last year was the year to do it. Y'all should have done it for Algebra 2 because I think we only had 2 students total.
I didn't
Do
know
it.
word about it. This is the first time ever hearing about it. I
Yeah.
honestly might have done it last year.
Well, the thing about last year is I think there was only 2 Algebra 2 students who did it. So even if you got
Automatic.
0 questions right, you could still put on your applications that you got 3rd place for Fayetteville High School, and you know they wouldn't know the difference. So that would have been true. Okay, so on the second handout, number 80, I would like you to treat this as a practice quiz. So please don't look at your notes. Just read each question, see how you would do, see which parts you knew coming into today, plus whatever I may have just refreshed you on, and we will go over it when this timer is up. And we'll make sure that there's not any follow-up questions you need to ask and to identify what it is you need to review between now and Wednesday. But again, we don't spend much time on this. This is more or less just trying to help us out when we transition from exponentials to logarithms.
So Townsend, what's your favorite unit to teach out of pre-cal or calculus?
Oh man.
If you know.
Maybe the trig proofs first semester for pre-cal, where you make the left side look like the right side.
Yeah.
But that may just because I like to do them. I feel like they're like little puzzles. So I don't know if that's because I like to teach it or not.
Well, it could also just be your favorite thing. It doesn't have to be.
Yeah. And calculus is probably
Yeah, yeah.
like volume of irregular shapes like these.
Oh.
If you wanna know how much volume something like this has,
Yeah.
that you can't just plug numbers into a geometry formula. We do that, that's like one of the last things we do, so we haven't quite done that yet, but that usually blows students' minds.
That sounds miserable.
No, it's actually pretty easy. But you don't know the calculus to understand why it's set up the way it is, but. There's a thing in calculus that we use that like is a way to add up a bunch of stuff. It's called integration. So right now what my students are doing in calculus is we're integrating. This is a little integration thing. You can integrate something to find area. So even if it's got curvature to it and it doesn't fit a nice neat geometry formula, we can figure out exactly how much area this has. What they haven't done, and they will do here in a few weeks, is they'll take this like 2-dimensional area and then they'll spin it, which makes a 3-dimensional shape.
Yeah.
And then, so integration will also find that.
Oh.
That sounds like awful.
No.
It's kind of cool that you can do that.
The arithmetic is actually not very bad at all,
Yeah.
and it just kind of unlocks some really
I mean,
unique
it's cool,
stuff.
but like I don't
Yeah.
want to do the math.
You just plug in a function.
Right, when you know what you're gonna do, well, and Ben, senior year,
Some probably BC.
BC.
Yes, English. I figured
BC.
that's calculus BC.
Ah.
Yeah, because we're about.
Why is it BC? What does that stand for?
So AB's calculus A and the first half of calculus B. And calculus B saves the second half of calculus B and calculus C.
Is calculus B like calculus 2 or?
Actually, the B is the same.
Okay.
A, B, and
So
BC.
there's different types of calculus? Or like, wait.
There's calculus is too much to learn in 1 year. Just like algebra, you don't just do 1 year of algebra. You do multiple years of
So
algebra.
there's it's just like.
Segments.
Cal AB
Yeah, I'm
is,
just doing algebra.
and in high school, Cal AB is comparable to college Cal 1 and about half of Cal 2. And then BC is review of AB plus about half of the other half of Cal 2.
I'm really glad I'm not doing that.
But for those students that get to take BC while you're still in high school, if you pass the AB AP exam, you get Cal 1 credit. If you pass the BC AP exam, you would get Cal 2 credit. And if you want to be a math major or get a math degree, then you got to take a bunch more math classes. But if you want to be an engineer, which is one of the degrees that requires the most math, you only need Cal 3 and differential equations. So 1 more year of math. And you would have all the math you needed to be an engineer.
No, that counts. The AB thing.
Yeah.
Why?
You were doing it?
Why didn't I know it?
I thought you were.
Well, the point of AP classes are to try to get college credit.
I guess I just forgot that Cal AB was an AB class. I mean, I don't know why it wouldn't be, because it's like up there, but I just,
Oh yeah.
Yep,
I don't know.
it's an AP class.
I think
It's
I wanted
tough,
to
though.
do something. I still don't really know all the math, but I'm sure that would be possibly helpful.
Maybe, I don't know. If you Google search the major you think you want to go in and see how much math you need, you probably figure it out pretty quick.
Yeah. I'll have to do that.
How much time do we have? Working?
Great.
It's still got 10 minutes.
Okay.
Although I might add a minute or two because people have questions.
For number 3, do you just sketch one graph on the thing?
Yep, anything that you think matches that. There'll be multiple correct answers there.
Or do I need to write it like?
Either one's fine. If it said interval notation, then it would need to be written like this, but if it doesn't say, either one's fine.
Okay.
Usually in higher math, interval notation is what we lean towards, but. Okay, do your best to try to have those answered in the next 2 or 3 minutes, please. Let's see how you did and make sure you guys don't need to ask any questions. Okay, so starting off on question 1 gives us a bunch of points. And then wants to know the ordered pair that would go with the inverse. So to get a point and change it to a point that would be on his inverse. just switch the input and the output, which in our case is X and Y. I don't know why there's so many points to make that, but switch X and Y. We okay with that? Okay, number 2 gives you a little bit more of a clue than you should expect on the test or the quiz. This says verify that these two are inverses of each other. What we don't have to tell you is that you do that with composition of functions, and we certainly don't have to tell you that this is how you do that, so make sure that that doesn't help you out too much. But you should have taken all of this and plugged it in here. Simplified it and show that it goes to X, and you have to go the other direction as well. You have to plug all of this in over here, simplify, and shows that that goes to X. Both directions simplify to X. That's the only way to prove or verify that two functions are inverses of each other. Okay, anything y'all want to ask about number 2? Okay. Then number 3, there could be several correct answers here. So the fact that A says it needs to be a function means that yours has to pass the vertical line test. So I don't know. I usually just start off with the easiest thing that I can. This passes the vertical line test. But then not to be one-to-one, we need this to be true. To not be one-to-one, we need the horizontal line test to fail. So this that I currently have written down is not good enough because mine passes the horizontal line test. So I would try something, I don't know, something like maybe x squared. This is a function, it passes the vertical line test, but he does fail the horizontal line test. So that's one possibility. You guys can put anything you want to, as long as it passes the vertical line test and not the horizontal line test. And if you're not sure if yours is okay, I can check that for you once we're finished here. Part B though says it wants it to be a function, so your answer better to pass the vertical line test, and then to be one-to-one, he also needs to pass the horizontal line test. So the same answer I put for part A does not work for part B, because this fails the horizontal line test and I need it to pass. My advice would be just to make the easiest thing that you can think of. So I just make a linear line. Passes both. Don't try to overcomplicate it. Same thing though, if you want me to check yours, I would be happy to do so. Okay, question 4. Same thing, it's giving you a little bit more information than you should expect the quiz to. Should not expect the quiz to tell you how to find an inverse function. We really should take this off. But your steps should have been switch x and y, solve for y, and this guy can't equal y and this guy equal y because they're equal in two different things. So your final piece shouldn't say y equals, it should say the inverse of f is that. Not many steps, but if you don't know what the steps are, then there's not much else you can really do. Now, I don't really remember, I think I figured out one year why this was on here, but for whatever reason, they want us to do a t-chart with this. So if we plugged in 0, solve for y, plug in 1, solve for y, plug in 2, solve for y. So it seems kind of unrelated to me. But what I think is probably the second hardest question on this entire handout is this. But I can give you a hint, 2 different ways that you can try to find this. So this gives you some options on the quiz, or you could just do both and use it as a little bit of a check. So one thing that you could do is you could force yourself to say, if I know the domain and range of the function, I know that's going to become the range and the domain of the inverse function. So right here, they're giving us a restricted domain. They're saying the domain is 0 or bigger. So if the question was, what's the range of the inverse function? It would be 0 or bigger, because those two are the same. But for the range is really hard to do algebraically. So basically what you got to do is think about what this graph looks like. X squared is just a normal parabola. Shifted down one is going to look like this. So if I look at his y values that he hits, it's -1 to infinity. And the reason why that's relevant is because the range of the function is the same as the domain of his inverse, which is what this question was asking for. So understanding that relationship gives us that as an option. And or your other option is, if this is what the inverse is, think about what this looks like as a graph. The square root of x is a parent function, so I hope that you know what it looks like, but you could also make a table and plot a few points until you figure it out. And what is the +1 going to do to the graph if it's next to x? Shift it left 1. And so if you do that, you can visualize the domain is -1 to infinity. So second way to find the same answer. Of course, on your quiz, I'd recommend you do it both ways. So I can go back over a part of that if I need to once we're finished here. But then question 5 is just like question 1, just phrased a little bit differently. If you have some points on a function, switch x and y, and you've got some points on the inverse. They're not opposite. I'm not just multiplying by a negative. I'm switching input and output. Number 6 is the hardest one. I'm going to skip it for just a moment and go down to question 7. If you want something to be a function, it better pass the vertical line test. If you want it to pass the horizontal line test, that's going to tell you that its inverse is a function. And if it passes both of those, you need to know that's called 1-to-1. So basically some vocab there. Everybody okay with that part? Okay, 6 is probably the most missed question that you guys had. And in the past, where I kind of go around and see how people did, I'd say probably the most common answer that people pick is not possible. But this is possible. So we got to make sure that it's not because you don't know something here, or it could be that you just gave up too quickly. So first off, it says you're supposed to come up with a function. So that means our final answer needs to pass the vertical line test. It's not supposed to have an inverse function, which means we have to stick with this until it fails the horizontal line test. And we need it to be an odd function. So let me remind you what it means to be odd and the difference between an even function. An odd function is symmetric to the origin, meaning you could rotate your paper upside down, 180-degree rotation, and it's going to look the same. The most common odd function is x cubed. That graph looks the same that way or upside down. Even functions are symmetric to the y-axis. The most common one is x squared. Just gives you a quick little visual that you can see it's symmetric to the y-axis. So the first thing I would probably do on this is, well, I've worked this question out enough years that I kind of know what to do, but I would just start off with something. So I know x cubed is odd. It passes the vertical line test. Unfortunately, it also passes the horizontal line test. So this is not quite enough here. But if you didn't give up too quickly and you're creative enough, you can come up with something that looks like this. Just give it a little bit of a bump and keep the symmetry. And because it keeps that symmetry symmetric to the origin, I know it's odd. It passes the vertical line test, so I know it's a function, but it no longer passes the horizontal line test, so I know his inverse is not a function. So that's not something that immediately jumps out at people, but you have to have a little bit more background information there, and you had to not give up too quickly. But okay, so while all this is fresh in your head, again, I hope that you remembered all of it. That would be great. But realistically, if you forgot a few of these things and you think it would be beneficial to look them over before our quiz, you should probably circle those questions. And if you guys have anything you want me to discuss about any of these before we put it away, then I would be happy to help. How much of this do you remember? Like half of it? That's about right?
6 was like the only one that gave me trouble.
Yeah, 6 is a little tricky.
I remember all like the terms and stuff.
Okay, so if you do find that you have any more questions, please make sure you ask. We will quiz, and the quiz will be pretty similar to this worksheet. First thing on Wednesday, I will ask for number 80 for a homework grade before we start the quiz, but it is also open in Google Classroom. If you want to just turn it in and be done with it, then that, of course, is encouraged. But that's all I've got. So make sure that you're prepared for that. Make sure you've marked up your notes or your practice quiz so that you know what you need to scan over on the day of. And then we will quiz that next time and then move in straight into exponentials.